Guys, so this lesson is our second lesson on angles, and it is the lesson entitled Angle Bisectors. So we talked about something last week about segment bisectors, and a segment bisector was a line, a ray, or a segment that bisected a segment, so it cut it in half. An angle bisector is going to be the same, but it's a ray that divides an angle into two congruent adjacent angles. So just like the segment was cut into two congruent pieces, the angle is also cut into two congruent pieces. So if we look at this picture here, we have that ray CD is bisecting angle ACB. So since they told us that it's bisecting, that means that this half of the angle is the same as this half of the angle. And we show angles congruent by making the little arcs inside them. If you have multiple angles with different congruencies, you would use different markings for each angle. So since we know it's bisecting, then we can say that angle ACD is congruent to angle DCB. It is important to note that you must have C in the middle of both of those angle names, as it is the vertex of both angles. You also can see that those two angles are adjacent because they share the ray CD. Remember, ray CD is named that way because C is the endpoint of the ray, thus it goes first. Moving on to example 2, we have that ray RQ bisects angle PRS. So we can go ahead and label that these halves of the angles are congruent with our little congruent arcs. Then let's go ahead and label that the measure of angle PRQ is x plus 40, and the angle of QRS is 3x minus 20. From there, we want to say what statement we can make. Since we know that the angle PRQ is congruent to the angle QRS, then we also know that their measures are equal. So the measure of angle PRQ is congruent to the measure of angle QRS. Since they're equal, we just set the two expressions for each angle equal to each other. Then we just solve the equation. So we would minus the x from both sides. So that's 40 equals to 2x minus 20. Add 20 to both sides. And we get that 2x is equal to 60. Dividing by 2 gets that x is equal to 30. So since we know that x is equal to 30, in order to find PRS, which remember is going to be the entire angle PRS, then we will plug in our x equals 30 for x. So we would have 30 plus 40, which is 70. And then we'd have 3 times 30 minus 20, which is 90 minus 20, which is 70. It's good to go ahead and check to plug into both angles, just like we did with segments, to check that we did it correct. Once you've done that, the angle PRS is just the measure of angle PRQ plus the measure of angle QRS. So that's just going to be equal to 70 plus 70, which is 140. So the measure of angle PRS is equal to 140 degrees. Okay. Down in examples 1 through 5, they're telling us that EF bisects angle DEG, and that the diagram is not drawn to scale. Obviously, those angles don't look congruent. But they told us EF, so that's ray EF, is bisecting DEG. So DEG is the entire angle. So that means we can label this congruent to this. All right. So if the measure of angle DEG is 80 degrees, so DEG, I'm just going to draw a little mini angle here. DEG is 88 degrees. So that means this entire angle is 88 degrees. Then they told us that the measure of angle FEG, so FEG, is what we're looking for. Well, they didn't tell us anything about an expression, so we just let it be x. Well, since we know that DEG is being bisected by a ray EG, then we know that DEF is congruent to FEG. So this would also be x. So you could set up your equation, whoops, oh man, to be 2x is equal to 88 degrees. We could then divide by 2 to get that x is equal to 44 degrees. You could have also just remembered to do half of 88 to get the each half. So now we're looking at number 2. So we're going to draw that same picture again. So angle FED, so FED is FED, that's this side, is 27 degrees. They want us to find the measure of angle GED. So GED is this entire angle. So if I know since I know that this angle is being bisected, I know that FEG, so the measure of angle FEG, is equal to the measure of angle DEF. So both of those angles are 27 degrees. So the measure of angle GED is equal to the measure of angle FED plus the measure of angle FEG, which would be 27 plus 27, which is 54 degrees. Now let's look down here at number 3. I'm going to kind of move this over this way a little bit. So we have our angle DEG bisected by EF. So we know those are congruent. All right. Labeling my picture, DEF is 3x plus 1. So that's this one. And DEG is 5x plus 19. DEG. And so that entire angle is 5x plus 19. It's important to use something to help you remember how to name them, maybe tracing them in different colors, or even just labeling your picture so you can see what pieces you have. For this problem, 3x plus 1 does not equal 5x plus 19 because 5x plus 19 is the entire angle. So I would need to do the measure of angle DEF plus the measure of angle FEG will equal the measure of angle DEG. I know that DEF is 3x plus 1, and I know that DEG is 5x plus 19. This will work just like the segment bisecting that we did, where we just use the measure of angle DEF for the measure of angle FEG. So we would just say 3x plus 1 again, since we know that those two angles are congruent since it's been bisected. Then from there, it's just solving the equation. So we just want to combine our like terms. So 3x plus 3x gives us 6x. 1 and 1 gives us 2, and we're equal to 5x plus 19. Solving for x, we are going to minus the 5x from both sides, as well as minus the 2. So we get that x is equal to 17. Knowing that x is equal to 17 can help us find the rest of the angles. So x is equal to 17. So the measure of angle DEF was 3x plus 1. So the measure of angle DEF will be 3 times 17 plus 1, which gives us 52 degrees. The measure of angle DEG will be 5 times 17 plus 19, which will equal 104 degrees. 52 is half of 104, so that helps us to know that we did the work correctly. Looking now at number 4, we're going to set it up the same way. That's supposed to be a G. Okay, so they told us the measure of angle DEF, that's that one, is 5x minus 3. Then they told us that FEG, so that's this one, is 2x plus 15. So they want us to find x, f, DEF, and DEG. This one is different because they gave us 2 halves of our angle. So if you notice in number 3, they only gave us 1 half of the angle and then the length of the entire, not the length, the measure of the entire angle. But in number 4, I have my angle of each, an expression to represent each side of the angle. So since I know each piece of the angle, I can set those two things equal to each other because I know that they're equal. So 5x minus 3 is equal to 2x plus 15. So then I'm going to minus the 2x from both sides, as well as add the 3 to both sides. So 3x is equal to 18. Dividing by 3 on both sides, I get that x is equal to 6. Knowing that x is equal to 6, I can plug in to find the measure of angle DEF. So that's 2. That's 5 times 6 minus 3, which would be 27. And then the measure of angle DEG would be the entire angle. So you would want to do 2 times 6 plus 15, which is 27 as well. So you know that they're the same. So that means 54 degrees is your angle. You guys try number 5 and then check back. So they gave you 2 halves of your angle. So since we knew they were congruent, we could just set those 2 halves equal to each other. Minusing 2x and adding 7 gets us an x of 12. Then we just needed to plug in 12 for x to find the measures of each of the little angles to get the measure of the big angle. I always recommend plugging into both angles because if they're not the same, then you know you've done something wrong and you can go back to check your work. So your final answer should be x equals 12. Measure of angle DEG is 130 degrees. Please list out any questions that you have, and then tomorrow we'll go back through this and I will do more examples to help you get a better understanding of angle bisectors. I hope this was helpful and I will see you tomorrow. Make good choices.